Hello everyone, myself Vasant Kumar HS, working as a assistant professor in Department of Mechanical Engineering at Government Engineering College. I welcome you all to the lecture session on mechanical actuation and electrical actuation system as a part of 7th semester subject called mechatronics. So this video session is a part of learning management system under the Department of Collegiate and Technical Education. This session is the continuation of the session 1 on mechanical actuation systems. We have different types of mechanical actuation systems and electrical actuation systems. In mechanical actuation systems, we have gears, cams, and belt drives, whereas in electrical actuation system, we have drives, switches, solenoids, and electromechanical relays, motors, and its types. First of all, we try to understand the mechanical actuation system known as gears, right? So what are gears? Gears are the toothed wheels used to transmit power from one shaft to another shaft. When these gears or the tooth wheels are arranged, right, to transmit power. For example, when two or more gears are used to transmit power, the arrangement is called as gear trains. We have different types of gear trains which are classified as simple gear trains, compound gear trains, riveted gear trains, and epicyclic gear trains. The number of gears in the gear train depends upon the desired velocity ratio and the relative position of the axis of the gear shaft. The gear wheels used in gear train may be spur gear or bevel gear or helical gear, etc. Next, we move on to the simple gear train. In simple gear train, each shaft between the driving and the driven shaft carries only one gear. Then it is known as a simple gear train. So this is the diagram which represents a simple gear train, where A represents the driving gear and C represents the driven gear, whereas B represents the intermediate gear, which is also called as idler gear. Because the gear ratio depends only upon the number of teeth on the driving and driven gear. So the intermediate gear is called as idler gear. So here this is a simple diagram of a simple gear train. The next type is compound gear train. So here the diagram represents a compound gear train where each shaft carries two or more gears. Then the gear train, it is called as compound gear train. When the gear ratio is high, the simple gear train becomes practically impossible connecting the driving and driven for a given center distance. Then we use this compound gear trains. When two gears wheels are mounted on the same shaft, the angular velocity and the speed remains the same. So this is about the compound gate. The next is belt drives. So we know that belt drives are used to transmit power from the prime mover to any device. So this is the simple diagram of belt drives, which consists of a driving shaft and a driven shaft, and this is the belts which are used, right, which has the contact with the pulley. So belt drives are used to transmit power from prime mover to any device, and also transmit rotational motion to various parts of the machine, and are largely used for general purpose in mills and factories, especially when the center distance, when the distance between the two shaft is not very large, we use this belt drives. So we have two types of belt drives. One is open belt drive and another one is cross belt drive. So in open belt drive, the driver and the driven pulley or the shaft rotates in the same direction as shown in the figure. Whereas in cross belt drive, the driver and the driven pulley rotates in the opposite direction. The basic difference between these two drives is the in cross belt drive the power transmission capacity is more than that of open belt drive, and the velocity ratio is also more in case of cross belt drive than that of open belt drive. And there is, as the center distance between the two shaft is too large than that of cross belt drive, so there is a problem of belt whip, right? There will be a problem of a belt slippage in case of open belt drive, whereas the cross belt drive there is no belt whips or a problem arises. So this is the basic difference between the two types of belt drives. Next, the next one is chain drive. So chain drive is also a mechanical actuation system, wherein this chain are the flexible connectors composed of metal links used for motion and power transmission. So these chain drives are used where a positive drive is required, but it cannot be used where precise timing is a requirement. So it cannot be used where the precise timing is required. So these chain drives are suitable for long or shorter distance drive, and give more compact drive than is possible with the belts. And the gear ratio is as similar that of a simple gear train. So this chain has the same relationship for the gear ratio as in the case of simple gear trains. The next one is the mechanical aspects of motor selection. So what are the aspects which has to be considered for selecting the motor? When selecting a motor for a specific application, engineering application, we must consider the factors such as speed range, torque speed characteristics, reversibility, duty cycle, and starting torque, and the power which is required. See, the torque speed curve provides us the information in selecting a motor for a specific application. So the curve displays the torque and the motor, and can deliver at different speeds at different rated voltage. The factors that have to be considered are load, inertia, and torque. So now we will discuss electrical actuation system. So just like mechanical actuation system. So in electrical actuation systems, we have drives, we have solenoids, we have electromechanical relays, and we have motors. So now we'll understand what are these drives. So the basic function of CNC machine is to provide automatic and precise motion control to its elements such as work table, tool, spindle, etc. Drives are used to provide such kinds of controlled motion to the elements of a CNC machine tool. So basically these drives provides the controlled motion to the elements of a CNC machine tool. A drive system consists of drive motors and ball lead grooves, and the control unit sends the amplified control signals to actuate drive motors, which in turn rotate the ball lead grooves to position the machine table or cause rotation of the spindle. Solenoids are nothing but the electrical actuation system, and solenoids are the piece of wire wound in a shape of a coil. When we place a metal core inside the coil and pass an electric current, so this coil generates a magnetic field, and the lines of magnetic fields are concentrated on the surface of the metal core, and in turn it increases the induction of the coil. So this mainly the solenoid works on the principle of electromagnetism, and the solenoids are used in simple locking devices, and these are used in electromagnets and medical clamping devices. The next one is electromechanical relay. Electromechanical relay are the electromagnetic devices which converts the magnetic flux by the application of a low voltage electrical signal, either DC or AC electrical signal. So these are used in automotive applications, and also these are used in electrical fuel pumps and industrial applications. DC or AC motors classification. So electronic motors are classified into AC motors and DC motors. These AC motors are classified again into synchronous and induction motors, whereas DC motors are classified into brushed and brushless motor. So we will try to understand what are these AC and DC motors. So alternating current and direct current are the input for the motors. Basically these motors consist of stator, rotor, armature, and the shaft are the basic components of the motors. So the definition of current is the flow of electric charges. When the flow of electric charges varies with respect to time, then that is called as alternating current. When the flow of electric charges are does not vary or constant in nature, then it is called as a direct current, and the input the current is called as direct current for the direct current motors, and for the AC motors alternating current are the input. Say DC motors. DC motors is a device that converts direct current into a rotation of an element. That is, it converts electrical energy into a mechanical energy. So the two types of motors are DC motors are brush type mode DC motor and brushless type DC motor. Brushed DC motor. So the diagram represents the brush type DC motor where this is a stator magnet and the rotor is wounded with the coil, and we have the commutator and we have the brushes in the brushed DC motor. And what are the advantages of the brushed DC motor? The design of the brushed DC motor is very simple, is quite simple, and the controlling of the speed of a brushed DC motor is very easy and it is very cost effective. The disadvantage is the maintenance of this brushed DC motor is high and performance decreases with the dust particles. When there is more dust particle, the performance decreases and less reliable in control at lower speeds. And the brushes wear off with the usage. This is the main disadvantage of the brush DC motor. And the brushless DC motor. So here the main advantage of brushless DC motor is more precise due to computer control and more efficient and less electrical noise and no sparking due to the absence of brushes. So here brushless DC motor, in the absence of brushes, there is no sparking due to the absence of these brushes. No brushes wear out as it does not have the brushes, whereas in brush DC motor it has brushes, and there will be a wear out of that. So electromagnets are situated on the stator, hence easy to cool. So the electromagnets are situated on the stator, and motor can operate at speeds above 10,000 rpm under loaded and unloaded conditions. Responsiveness and quick acceleration due to low rotor inertia. These are the main advantages of the brushless DC motor. And the disadvantage is the higher initial cost is required and complex due to the presence of computer controller. So it involves a computer controller. So there is a complex system involved in it, and this is the main advantage. When we have a more complex system, so there will be a complication. And brushless DC motor also requires additional system wiring. So this is the main disadvantage of the brushless DC motor. Now these are the references we have gone through, and now we have come to an end of the discussion, and these are the multiple choice questions. The number of teeth on a wheel per unit of its pitch diameter is called diametrical pitch. The next question, the type of gauge used to connect two non-parallel and non-intersecting shaft is a spiral gear. To connect two parallel and coplanar shafts, the following type of gearing is used. Which type of gear is used to connect parallel and coplanar shaft is the spur gear. Which of the following type of the gear train, the first gear and the last gear are coaxial? So the answer is reverted gear train. Which gear train is used for higher velocity ratio in a small space? So here we have four options: simple gate train, compound gate train, reverted gate train, epicyclic. So here epicyclic gate train is used for higher velocity ratio in small space. Power is transmit by belt is dependent on arc contact between belt and pulley, velocity of the belt, tension under which belt is placed on the pulley, all of this. So here yeah, all of these are contact between belt and pulley, velocity of the belt, tension under which belt is placed on the pulley. Coefficient of friction between belt pulley is dependent on all of this. Slip of the belt, speed of the belt, material of the belt. If a speed of the belt is increased, then coefficient friction between belt and pulley is decreased. Coefficient friction between belt and pulley is increased. Power transmission is decreased. Power transmission is increased. So power transmission is decreased if the speed of the belt is. In belt drive, idler pulley is used for applying tension, increase velocity ratio, changing direction, increase life of pulley. So it is used for applying tension. The last one, all stress produced on belt are either tensile stress, compressive stress, shear stress, or bending stress. So here the stress produced on a belt are tensile stress. So thank you for the patience listening, and these are uh, the list of coordinator and the content developers. So thank you very much.